MACHHOLZ, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 45, for the week of November 11th, 2020. The related website for this podcast is donmachholz.com. That is spelled D-O-N-M-A-C-H-H-O-L-Z. 2 H's. What's up in the sky this week? As our week begins on Wednesday, November 11th, the moon is a crescent in our morning sky, reaching new moon on November 15th, 0506 Universal Time. By the end of our week, Tuesday, November 17th, the moon will be a crescent in the evening sky. Bottom line, moonless sky. Those wishing to see a very slim lunar crescent in the morning sky might want to look for the moon on the morning of Saturday, November 14th. The northern hemisphere is favored for this morning sky event, as the ecliptic is favorably aligned and the moon is north of the ecliptic. For those wanting to look for the crescent moon in the evening sky after new moon, the southern hemisphere is favored on the evening of November 15th. The moon passes just north of the planet Venus in the morning sky about 0000 hours Universal Time on November 13th. And 23 hours later, the moon passes just north of the planet Mercury, which is 19 degrees from the sun. Yes, Mercury is not far from the sun on this visit to our morning sky, but the northern hemisphere is favored for seeing it in the pre-dawn sky. Last week, I discussed a meteor shower named the Northern Taurids, which peak on Wednesday, November 11th. The radiant is in the constellation Taurus, and it's rising at evening twilight and overhead an hour after midnight. The number of meteors it produces are few, perhaps 5 per hour, but they can be very bright, so watch for those. A second meteor shower graces our morning sky. It is a Leonids. The radiant is about 10 degrees north of the star Regulus in the constellation Leo. This area rises shortly after midnight and is highest in the sky at morning twilight, so this is a morning shower. It peaks on the mornings of Monday, November 16th, and Tuesday the 17th. These meteors come from the comet 55P Tempel-Tuttle, which orbits the sun every 33 years. It was last here in 1998 and will return in 2031. The debris trail, which causes the meteors, is what we want to be traveling through if we're going to see the meteors. It put on a good show in 1966, and in 1999 we had another good show. But even though the comet keeps coming back every 33 years, the debris trail is presently missing the Earth each year, and it will be several decades before we pick it up again. Therefore, the number of meteors we are expected to see this November 16th and 17th is only about 15 meteors per hour. So we have 2 meteor showers after midnight. Is the best time to watch both of them. The evening sky has 3 bright planets worth study: Jupiter, Saturn, and Mars. In 2 months, both Jupiter and Saturn will be too close to the sun for observation, and Mars will be 2.5 times farther from us than it was at its closest point in mid-October. So now is the time to get out and see those planets. Will you be able to see the International Space Station this week, which for our purposes begins Wednesday, November 11th through Tuesday, November 17th? Also, during the next week, it's possible we'll be having a crewed mission going up to the space station, so we might want to watch for that too. But this all depends upon your location. This week we have 4 zones. For those living north of 45 degrees north, the ISS will not be visible this week. From 20 to 45 degrees north, the International Space Station will be in your morning sky for the first few days of the week. Then for the second part of the week, it will be in your evening sky. For many of you this weekend, between 20 and 45 degrees north, it will be in both your morning and evening skies. In the equatorial zone, between about 15 degrees south and 20 degrees north, the ISS will be in your evening sky for the first part of the week, and for the second part of the week, it will start appearing in your morning sky. In some areas, it will be in both your morning and evening sky on the same nights. South of 15 degrees south, the ISS will not be visible at all this week. To determine where it will be in your sky, go to the website heavens-above.com and enter your location, then click on ISS. I have been reviewing a book I wrote and published in 1985 entitled A Decade of Comets. It is a study of the 33 comets visually discovered from 1975 through 1984. The series began in podcast 34. The book has 6 parts, and this week we start part 6, the orbital parameters. This will take us 2 weeks. The book is free on my website in sections. The first part can be downloaded in podcast 34. Then sections are downloadable each week since then. This week, download podcast 45, A Decade of Comets, part 6. In this part of the book, I listed the orbital parameters of all comets discovered visually from 1975 through 1984. Finally, I had the orbital elements laid out in Table 16 for morning discoveries and Table 17 for evening discoveries. I must say that I was disappointed when I looked over the orbits of these 33 comets. No similarities seemed to jump out at me. Comets came from all over the place. How close do comets get to the sun? This is known as the perihelion distance, and it's measured in astronomical units. 1 astronomical unit, or AU, is the average distance between the Earth and the Sun, and it's 93 million miles, which translates to 150 million kilometers. Why does this matter? The closer a comet gets to the Sun, the faster it travels into and out of the inner solar system, and the faster it brightens and dims. All other things being equal, a comet with a short perihelion distance, one going close to the Sun, will get brighter than one that does not get close to the Sun. And as we have learned again recently, comets that get close to the Sun are more likely to disintegrate. In our study, the average perihelion distance for all comets is 0.96 AU, slightly closer for morning sky discoveries than for evening sky discoveries, but not significant. That is for the 33 comets found in the decade 1975 through 1984. Now, when we look at a larger sample of comets, the 94 visually found since the beginning of 1975 through the present time, we find a median and average of 0.87 AU for the evening finds, while for the morning comets, the average is also 0.87 astronomical units, with the median being 0.78. So with the larger sample of comets, we still find the average perihelion distance for those visually found is a little bit under 1 astronomical unit. That is, they typically come closer to the sun than the Earth's orbit. So most of the comets visually found do get closer to the sun than is the Earth. And what about those comets that are nowadays found by automated search programs? They probably fall into 3 categories. Number 1, those automated search programs find comets which us visual comet hunters would have found if they had not found them. So they do find the bright comets, but they find them while they are still quite faint. Number 2, they find comets that get within about 1 or 2 astronomical units from the sun, but are intrinsically faint, so they never get very bright. The visual comet hunters probably would not have found those because they remain quite faint. And number 3, they find comets that stay well away from the sun. They never get closer than 3 or 4 astronomical units, and they therefore remain faint. 2 of the orbital elements for comets are the argument of the perihelion and the ascending node. In my book, A Decade of Comets, I plot those, but I found some groupings, but they did not seem to be significant. Now we look at the inclination, that is the tilt of the comet's orbit in relation to the Earth's orbit. This is measured in degrees from 0 through 180. Less than 90 degrees and the comet goes around the sun in the same general direction as we do. These are called direct orbits. An inclination of 90 degrees means the comet visits us from straight up or straight down from our orbital path around the sun. And if it's greater than 90 degrees, up to 180 degrees, the comet goes around the sun in the opposite direction than we do. Those are called retrograde orbits. We find a bunching up of comets at an inclination of about 45 degrees, and I'm not real sure why or if that is significant. Looking at the larger set of comets, the 94 comets visually found since 1975, we also have some bunching, with 18% of the comets between 47 and 63 degrees inclination. The final item we will look at this week is the L and B value of each comet. Suppose you were standing on the sun and noted the place in the sky where each comet came to perihelion, that is its closest point to the sun. You would examine that area and you would measure the longitude from the spring equinox, and that would be the L value in degrees from 0 through 360. You would also measure the angular distance above and below the ecliptic. A comet coming to perihelion on the ecliptic would be 0 degrees. North would be a positive number, and south would be a negative number. The positive and negative numbers can go up to plus 90 and minus 90. When the L and B positions are combined, we can see where the comets come to perihelion. Now the opposite numbers, that is adding 180 degrees to the L or subtracting 180 degrees from the L, and changing the sign on the B value, for instance, 30 degrees to minus 30 degrees, and you have the direction from where the comet came from. So what I wanted to see, is there any groupings of these numbers? That would mean there is a tendency for comets to come from a certain part of the sky. In Table 18, I grouped comets with similar L's and B's and looked at all the other orbital elements. This is what I found. No correlations. No comet families here. They're all unrelated. Next week, we finish up the book, A Decade of Comets. I'll talk about the shape of the orbits, the distance from the Earth and Sun at discovery, and the absolute magnitude of the comets. Interesting stuff. Now for the comets that you can see this week. The positions, that is, the right ascension and declination of these comets, can be found on podcast 41, Comet Positions. Our evening sky comet is Comet Howl 88P. It is slowly dimming and is at magnitude 9. It's very easy to find this week. On Friday, November 13th, it is south of Jupiter, 3.5 degrees south of Jupiter. And on Wednesday, November 18th, 5 days later, it's 3.5 degrees south of Saturn. It is plotted on podcast 45, map 1. In the morning sky, but rising a couple hours after evening twilight, is the comet 2020 M3 Atlas. It's moving northward along the west side of Orion. On the morning of Sunday, November 15th, the comet is in line with the belt of Orion, looking like a fourth star, in line with the other three to the west of the third star in the belt of Orion. It is much fainter than the stars, however. It's at magnitude 8, but this is a great binocular view. You will find it plotted on podcast 45, map 2. Also on podcast 45, map 2 is another comet, C2020S3 Erasmus. It is slowly brightening and sits at magnitude 9. Now is a good time to see it, as it is slowly creeping towards the sun's glare, and in another 3 weeks will be difficultly placed. And there is nothing worse than a difficultly placed comet. Well, except for a comet that disintegrates, and you spend lots of time looking for it only to find out later it has vanished from the solar system. And now is the time for me to vanish from this podcast. Until next week. You have been listening to Looking Up with Don, podcast episode number 45 for November 11th, 2020. I'm Don MACHHOLZ. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com, 2 H's. You can contact me at dontheastronomer@gmail.com. To repeat, once again, you can contact me at dontheastronomer@gmail.com. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's going on in the sky and finish up the book, A Decade of Comets. All that and more. Thank you for listening. See the sky this week. I'll see you next week.